Hi, my name is Patrick Bay. I'm the creator of CypherPoker, a cryptographic, peer-to-peer Texas Hold'em game. CypherPoker is unique because, as far as I know, there aren't many, if any at all, truly functional peer-to-peer poker games. The main reason that there are so few is that when trusted third parties like poker website operators are removed from the equation, we're left with a few conundrums. How can cards be fairly dealt and played? Who holds the wagers? And who ensures that winnings are properly distributed at the end? As it turns out, there are reasonable answers to all of these questions found in the world of peer-to-peer decentralized systems, and this has a couple of interesting implications. For starters, this effectively removes the house rake. That's not to say that games that exchange value would be entirely free, but any fees incurred as a result of verifying games would be distributed to the people contributing their computing power to the network, which can include the players themselves. In addition to this, there's a direction being established for the CypherPoker project that would allow contributors of all sorts to see actual benefits and rewards, and I mean more than just the great feeling that you've contributed to a kick-ass project. And I guess you could always try playing the game too. If this sounds interesting, then let me explain a little bit about how it all works, starting with the game part. Back in the late 70s, these three guys named Ron Rivest, Adi Shamir, and Leonard Edelman were fiddling around with mathematical equations called one-way functions when they made a really neat discovery. What they discovered was when they used one of these one-way functions a specific way, it could be used to mutually hide information between multiple parties, information that could later be cooperatively revealed. They published their findings to a paper named Mental Poker, which, as the title suggests, describes how one could play a provably fair game of poker with someone over the phone using just one's mind, and maybe a paper on which to jot down some calculations. If both players agree to some starting information, such as which numbers should represent which cards, they can then use the one-way functions to hide this information from each other. If this sounds like encryption, that's because that's exactly what it is. To be more specific, Mental Poker uses a commutative encryption system. This is a fancy way of saying that it doesn't matter in which order it's applied. For example, 2 plus 3 produces the same result as 3 plus 2. The fact that the order of numbers in addition doesn't matter makes addition a commutative operation. In the same way, even though each player in Mental Poker encrypts the cards, decrypting or undoing the encryption on those cards can be accomplished in any order. And although it may not be immediately obvious, this property is very important in Mental Poker. Of course, computers are way faster at crunching numbers, so software that can perform these calculations is an obvious next step. After that, you only need to make sure that the calculations use really big numbers. That way, the solution to the one-way function can't be easily computed by brute force. There are other pieces needed to build functional Mental Poker software, so it's not quite as simple as it may sound. In fact, it took me nearly 2 years, but this January, I finally completed a beta version of CypherPoker, which includes the major components needed for truly standalone, peer-to-peer gaming. The game still needs a lot of work, but it, along with plenty of documentation on how it works, are available to download and test right now. Of course, that's just the game. With the rise of Bitcoin, there came a wealth of innovation, including in one area called smart contracts. Much like the Bitcoin blockchain, smart contracts provide an immutable ledger in which certain values and actions in a game can be recorded. Unlike Bitcoin, however, smart contracts also contain complex programming instructions, like how to decrypt cards or how to compare poker hands to determine a winner. Much like Bitcoin, everyone on a distributed smart contract network like Ethereum verifies that transactions and calculations are correct, so the chances of cheating are negligible. What this means is that smart contracts solve the problem, in a fair and decentralized way, of who holds the wagers and how winnings are distributed. With Ethereum, there's the opportunity to create new, custom cryptocurrencies or to tie them to existing ones like Bitcoin. In fact, much of that functionality exists today and is getting tantalizingly close to its first official or safe version. This is especially exciting since I now have a working proof-of-concept integration between CypherPoker and Ethereum, proving that the pieces can be made to fit together. Problem is, this project is starting to grow a little too large for one person to handle, so I want to take this opportunity to reach out to you. Maybe you'd like to put your coding skills to good use. Maybe you can whip up nice designs. Perhaps you're a good writer, or maybe you're just interested in seeing this made because none of my goddamn business is why. With a distributed autonomous organization model, Almost everyone can be accommodated and rewarded for their contributions, whatever they happen to be. Here, smart contracts also play a role in establishing a trust that's cryptographically secured. Because smart contracts can hold value, that value can be replenished or dispersed based on how the contract is programmed. For example, there could be a monthly dividend that would be distributed to all contributors to a project from a smart contract. To me, this makes for an interesting and very timely discussion. However, I'd much rather do that on the CypherPoker Slack or subreddit, so please visit me there. In fact, there's a whole lot more that I would want to go over since I'm not assuming that, as a participant, you're particularly mathematically or cryptographically inclined. Seriously, I've almost got the explanation for the whole thing down to something that should fit on the back of a bar napkin. So please have a look at the links below this video to get you started, and thanks for your time.